Hello students, now we are going to discuss some important physical quantities. It is highly essential for the determination of the physical or chemical process, whether it is spontaneous or not. We know the spontaneous process, the process which takes place by itself, which continue by itself without the help of external factors, or initially by the help of external factors. Initially, by the initiation of the external factors, it will continue till completion. So this type of process is called spontaneous process. In natural process, generally all natural process are generally, we can say, that is spontaneous and irreversible nature. Natural process is a spontaneous process which is irreversible nature. So to study the spontaneity of reactions, whether physical change or chemical change, we have to know some other factors responsible for spontaneity of reaction. Let us discuss. First important thing is entropy of the system. Entropy. Entropy, it is represented by the symbol S. That is entropy. Entropy also is a physical quantity. It is one extensive quantity, you can say. And it is also a state function. It is extensive quantity, extensive nature, and that is a state function. The state function means only depends upon initial stage and final stage, does not depend upon the path of progress. So like enthalpy, internal energy, entropy is also extensive nature, extensive property, and it is a state function. Already we have discussed this, what is the meaning of extensive property and state function. What is entropy system? Generally it is measured by the randomness of the system, randomness or disorderliness of the system. How much disturbance it has? If the particles or molecules are more disturbed, are more free, then the entropy will be more. We can say this entropy is measured, the entropy change is measured. How can we calculate the entropy change? Entropy change is measured that when the system is isothermally reversibly expanded, when the heat is supplied to the system isothermally and reversibly, if heat is supplied, how much heat is gained by how much heat is absorbed isothermally and reversibly by the system per degree change in temperature, that is called enthalpy change. Enthalpy change can be calculated how much heat is absorbed by the system isothermally, very important, that is isothermally and reversibly. So it will change in enthalpy with respect to a constant pressure. Okay, isothermally and reversibly per degree change in temperature. That is also called as what? Entropy change. So entropy change, this randomness or disorderliness of system can be calculated in terms of amount of heat absorbed by the system reversibly and isothermally per degree rise of temperature. That is called what? Entropy change. What is the unit of entropy change? Unit is kilojoule per Kelvin. Kilojoule per Kelvin, this is the unit of what? Entropy change. Then what are the factors affecting entropy change? What are the factors? Factors, number of factors. First is physical state. If you see physical state, solid has low entropy than liquid, liquid has low entropy than gas. Because gas molecules are more free, they have no force of attraction, that's very negligible, and maximum space, that's why entropy is maximum in case of gas, then liquid, then solid. Second factor is number of moles. Entropy also directly proportional to number of moles. If you take more number of molecules, more number of substance, then entropy will be more, because more amount of heat will be taken. If you take more substance, more heat will be absorbed. That's why the entropy change will be maximum if number of moles, number of molecules are more. So this is the one factor also. Number 3 is entropy also directly proportional to temperature. Because if you see the formula, it will reverse. But this formula indicates when the temperature is very low, the amount of heat absorbed by the system will be very high. If the temperature is very, suppose example take two types of iron. One is very red hot iron, another is very cold iron. If you supply heat to the cold iron and to increase same temperature, suppose for 1 degree, 2 degree temperature increase for the cold iron and hot iron, if you see hot iron absorb less heat compared to the cold iron because already it possesses maximum heat. That's why at a very low temperature, if you increase the temperature, you increase the heat, then entropy will be more. That's why S is directly proportional to P. And another factor is S also inversely proportional to pressure. If pressure is more, entropy will be less. Okay? Then this is the very important factors. And entropy also is directly proportional to complexity. S is directly proportional to complexity. If complexity increases, if formation complex molecule will be formed, then entropy will be more. That's why if both sides number of molecules are more, but in the product side, if the complexity, if the large number of compounds are produced, if the size of molecule is more, then we can say that same number of molecule, if large, that is, if number of that is the particle size is greater, and that is called complexity. So complexity more means entropy is also more. So these are very important factors for the entropy. Entropy change, for calculation of entropy change, very important thing. If entropy increases, then entropy change is greater than 0. That means entropy increases. If entropy change decreases, that means less than 0. These two factors, these two things very important. If entropy increases, then entropy greater than 0. If entropy change decreases, is less than 0. If product side, that means here product side is greater than reactant side entropy. But this case, product side less than reactant side. This is the very important comparison. For example, let us discuss that entropy change. For suppose water solid convert to water liquid. And for example, heating of calcium carbonate and forming calcium oxide and carbon. This is the gas, this is the solid, this is your solid. Okay? In this case, and for example, dissolve sodium chloride in water, produce sodium chloride aqueous. This is the case. For example, H2 plus I2 both are gas, convert to 2HI. This is the case. For example, here suppose, you from this also we can know the difference. Here solids convert to liquid means delta S is greater than 0 because liquid has higher entropy than solid. That's why product side is greater than means entropy greater than 0. Here solid, both are 1 mole, but right side is 1 mole of gas left. That's why entropy is higher. Product side is higher means greater than 0. So this is still as this is solid form, low entropy. In aqueous state, molecules are ions are free. So entropy increases during soluble of substance. When the substance dissolves in particular solvent, that case entropy increases. Here in this case you see, here what happens, this side 2 molecules, this side also 2 molecules, both are gaseous state. But sorry, this is also G, this is also G, this is also G, this is also G. But here 2 molecules, here 2 molecules. But if you see, complexity is more because here the large size molecule is formed, here the small size and large size. That's why entropy increases. So these are the factors, very important things, that if you convert that gas, steam, suppose gas to liquid, condensation, if you use this method, then liquid, then entropy decreases. So these are the very important factors related to entropy change. Entropy change calculated, you have to compare the entropy value of the reactants and product. If reactants has lower entropy than product, then entropy increases. So these are the factors related to entropy change. But related to this, second law of thermodynamics, that is first laws and the zeroth law already discussed. Second law related to entropy. Second law of thermodynamics. What is the second law of thermodynamics? So second law states that entropy change of the universe is continuously increasing. It's very important. That is one statement. Entropy change of universe is continuously increasing. That means the randomness of the universe day by day is, complexity of universe day by day is increasing. You can say like this. So entropy change of the universe always increasing. Always entropy change of the universe, that is total entropy change of the universe is always increasing greater than 0. This is the one statement of the second law. The second statement of the second law is, for all spontaneous process, means natural occurring. All spontaneous process that is natural occurring is irreversible nature. That means all spontaneous, all natural occurring process is irreversible because we cannot bring back the same way that already we have converted the change. The change which is taking place, it cannot be returned back in the same way, same change. That's why it is irreversible. Natural occurring process, no doubt same thing will get, but the process by which the path of progress, every change of the progress will not be repeated. That's why for all spontaneous process is irreversible. For example, you cannot, water flows from what? Higher level to lower level. Lower level to higher level cannot be possible without the external factors. We also have the third law. What is the third law? What is the meaning of third law? That same thing. What is that? Without the help of external factors, without the help of external factors or external agency. The reverse that the spontaneous process cannot be reversed without the help of external factors. The spontaneous process cannot be reversed. Without the help of external factors, the spontaneous process can be. That means water can be always flow from higher level to lower level. Cannot be natural way that lower level to higher level water will flow. It is not possible. That's why spontaneous process, natural process can be reversed only with the help of external factors. This is that statement of what? Second law of thermodynamics related to entropy change. Entropy change of the universe is continuously increasing because the randomness of the universe, the complexity of the universe is increasing day by day. And all spontaneous process, that is natural occurring process, is irreversible nature. It is not possible to return back in the same way. But it may be possible, it return to the original state, but not the same way. That's why these are some concepts regarding entropy by the second law. And another thing is very important factors other than entropy can explain the spontaneity of the change, that is free energy change. Free energy that symbol is G or F. Different books use different that is symbols. What is free energy change? Free energy change it is a physical quantity. The decreased value of free energy is responsible the maximum work done. It is the driving force. The driving force whose decreasing value gives the maximum work done. The work done will be maximum when the free energy change will be decreased. If free energy change will be decreased, then maximum work, the positive way work can be done. So this is the very important significance of work done. Maximum work done by the system is possible when free energy change will be decreased. That means change in free energy must be negative decrease for spontaneous process. If entropy change is decreased, that means reaction is spontaneous, means feasible. That means feasible means possible. That means. So how free energy related to that entropy and enthalpy, that is the relation del G, change in free energy is equal to change in enthalpy minus T del S. Both are energy. Both factors are energy. This is also energy, this is also energy, this is also energy. And both factor del G is equal to del X. So this formula shows that not only enthalpy and entropy separately explain the spontaneity of reaction, but both together can explain the spontaneity of a reaction. What enthalpy change may be positive, negative, entropy change may be positive, negative. When both will be considered, then spontaneity reaction can be measured correctly. Whether the reaction is possible or not, whether reaction is feasible or not, only can be measured by that is free energy change, which gives maximum work done. That means del G is equal to negative value of del G is equal to W maximum. Maximum work can be done, and this del G and this del G is also calculated to minus NF E naught value. What is this? What is the value of N? N is the number of electron loss or gain. F is the Faraday constant. N is the number of electron, and F is the Faraday constant. Faraday constant, which is equal to 96,500 coulomb. The value of F is 9500 coulomb, and E naught is the what? That the E naught is the what is electropotential. Electropotential. Standard electropotential, that is cell potential of the cell particular change. For particular change, cell means you can say for redox. For particular change, what is the electropotential? And electropotential should be always positive. For the any change, maybe a physical change, maybe a chemical change, E naught should be positive. When E naught will be positive, automatically del G will be negative. If E naught will be negative, then the process cannot occur. It cannot take place. So this is the very important relation. Del G is equal to minus NF E naught, and del G can be also expressed in this way. Del G is equal to minus 2.303 RT log Kc. Del G is equal to minus 2.33 RT log Kc. Okay. What is this? Del G is equal to free energy change is equal to what? Minus 2.33 RT log Kc. Log Kc, this is the equilibrium constant. We will discuss in the equilibrium chapter detail, but it is a constant. This constant should be always positive. When the higher value of Kc, then del G will be automatically minus. Okay, when log Kc will be positive, the whole value will be negative. R is a universal constant, always it is positive. T is the Kelvin temperature, that is absolute temperature is also a higher temperature. So, greater the temperature, if T will be more, then the value of del G will be more negative, it will be more spontaneous. Then the reaction will be more feasible. So, greater the value of T, greater the value of Kc, del G will be more negative. Del G proportional to T. Negative value of del G proportional to T. Negative del G value also proportional to Kc. When equilibrium constant will be more, then del G will be more negative. When T will be more, del G will be more negative. So these are the important also relation between and is free energy change. Free energy change also related to, that is what? Electropotential of the particular redox reaction, whether exothermic or endothermic, or whether it is your oxidation reaction, reduction reaction. For particular cell, for particular reaction, E naught value should be positive. If E naught value is positive, then del G will be more negative, it will be more spontaneous. So then another relation between these factors, how del G will be more negative. Del G will be negative if the first factor, if del H will be that negative. This case, del G will be more negative. Del G will be more negative. Here the case, del H should be less than 0 and del S should be greater than 0. These two factors. This is also one factor. When enthalpy change will be more negative, this side will be more negative, and del S will be more positive, then whole change will be negative. That's why it is always spontaneous. This is the case. Second case is possible if del H is greater than 0. If it is greater than 0 and del S is less than 0, this is the case. It is greater than 0, it is less than 0, then less than 0, and this will become positive, this is positive. So del G del G will be positive. This is the case. So del G will be positive. If del G will be positive, it is non-spontaneous. So this is the case when enthalpy change is positive and entropy change is negative. Both factor will be positive. Results non-spontaneity of reaction. So many factors we can apply. We can use for the spontaneity of reaction. So anyway, to get the result, to get the product, the del G must be negative. So you have to use so many factors. Either you can increase the entropy, or you can increase the temperature, or you can decrease the enthalpy. So many factors are responsible for spontaneity of reaction. Okay. Then write down this one. Next part we will discuss. Then third law of thermodynamics we will discuss. Third law. Zeroth law, first law, second law, and third law. Third law states that we know entropy of for a particular physical state increases when randomness increases. But according to third law, when the temperature decreases, the entropy decreases. So entropy of a perfectly crystalline solid entropy of a perfectly crystalline solid is 0 at 0 degree Kelvin. That means when the temperature is 0 for a perfectly crystalline solid where the particles are orderly arranged, there is no disturbance, there is no desertness. In that case, entropy of this type of solid is 0. Means very minimum. 0 means in the what sense? The value is much more less for perfectly crystalline solid, where the desertness, randomness is negligible. In that case, entropy is taken as 0. So, entropy change for a perfectly crystalline solid is expressed in terms of enthalpy change at constant pressure with temperature. Okay? If you derive this one, that del H by T, we know del H by T is entropy change in enthalpy per degree temperature. So this del S can be del HP can be written as Cp into dt. What is this? Cp is the heat capacity at constant pressure and dt is the temperature. If you multiply, you get the enthalpy change upon T. So for whole change with change in temperature, it will be the Cp dt upon d, temperature 0 to T integration. So this expression is the entropy change for the, but we can write this one also in this form, that Cp log T 2 point, that is, you can write also this one 2 point, okay, Cp 1 by T integration of 1 by T, integration of 1 by T is equal to that Cp into 2.303 log T, and here temperature is 0 to T. So we can say the value is G, that how much it will be? The value will be this much value, because when you put temperature 0, that will log 1, log 0, 1, so this is the value. So this expression that you can bring 2.303 log, that is Cp, we bring also left side, then integration we can say that dt upon T, okay, 0 to T. So this is the expression. Sorry, this is the, you can take this one also. Without log 2.33 will not be written. Without log there will be no 2.3 multiplied. When you convert log, then 2.3 multiplied. So this is the expression that Cp del S will be Cp into integration of 0 to t of dt and t. This expression, this is the third law of thermodynamics. It is if you draw a graph, this type of graph you draw, this is your temperature and this is your entropy change. Then if you start from 0, that means entropy is 0, but it will move like this one. So this change at this temperature, this is your transition. This is the transition state. This is your transition state. Okay, and this is your fusion state, and this is your vaporization state. So this temperature Tm up to this Tm, this is your this temperature of Tf fusion, and this temperature is, that is boiling. So this is the entropy change. Entropy change is maximum in case of, if you see, evaporation. Entropy change is maximum and your also temperature also maximum. But in the transition, entropy change is minimum, you see. So this is the relation between different change in physical state, fusion, evaporation, and how much entropy change takes place. So this is the relation between temperature and entropy change for the particular, generally it is discussed for a perfectly crystalline solids. Okay, so this is about the entropy change and spontaneity of reaction, how the spontaneity of reaction related to free energy change. Free energy must be negative for spontaneous process. For every spontaneous process, del G must be negative. If del G is positive, the reaction is not possible. Okay, now we'll derive one important formula, that relation del G total del G, that is del G change, del G of the system, del G is equal to minus T del S total. This formula will derive. It will be derived like this. That we know that entropy change of the universe is equal to entropy change of the system plus entropy change of the surrounding. As per the universe is total entropy change is equal to universe. So this entropy change del S system plus here del S surrounding is equal to, we know del S is equal to delta H by T, that is equal to delta H by T. This is for surrounding. Okay, but if you write del S system plus, okay, here del S surrounding can be written as minus del S system by T. Because when system surrounding enthalpy change, always opposite. If surrounding is replaced by system, the sign will be changed. Delta H surrounding will be minus delta H system, because if one is absorbed, other will be evolved. So there will be exchange of heat between system and surrounding, so sign will be changed. Now what happens? You multiply T in both sides. So this is the del S what? You can say this is del S total. Universe means total. So if you multiply T, then T del S total is equal to T del S system minus del S system by T. Now T is cancelled. Sorry, here T will be cancelled because T is multiplied both sides means T part will be cancelled. Nothing will be left. Then what happens? If you write minus T del S total is equal to del S system minus T del S system. Okay? And this factor is equal to del S minus T del S is equal to del G of the system. Now changing del G is equal to del S minus T del S. So we got now del G system is equal to minus T del S total. So this is the derivation of the what? Free energy change with respect to entropy change. Here for the system, here for the total. So in terms of total means entropy change of the universe, total system and surrounding. Here with respect to entropy change of the system, it should be negative. When del S total will be positive, then del G will be negative, then reaction will be spontaneous. So this is very important comparison, relation, important formula for the enthalpy, that is free energy change and entropy change. Okay, thank you.